In this video, we're writing deductive proofs. And the first thing to get straight is what a proof isn't. Because the natural instinct here loses every mark on the question. Here's the question. Show that x plus 3, all squared, minus x minus 3, all squared, equals 12x. Now here's what most people do first. Try a number. Let x be 2. Left side is 25 minus 1, which is 24. And 12 times 2 is 24. It works. Try another. Let x be 5. 64 minus 4 is 60. And 12 times 5 is 60. That works too. And that is worth 0 marks. It's evidence. It isn't proof. It says nothing at all about the third number, or the 10,000th. A proof has to cover every number at once, and there's only one way to do that. You never give x a value. It stays a letter the whole way down. We'll do this one properly in a minute. So, 4 rules. 1. Start on one side, usually the messier one, which is normally the left, because you want room to simplify, and you can't unsimplify. 2. Work down the page. Each line follows from the line above it. 3. Never write left side equals right side at the top and start moving things across. The moment you do that, you've assumed they're equal, and that's exactly what you were asked to demonstrate. And 4. Stop when you've arrived at the other side and say so. Equals right-hand side, or as required, or the little filled square, any of those. Just finish it. One caveat on all that. Putting a number in is still useful. If x equals 2 makes your left side and your right side disagree, then you've made an algebra mistake, and you've just caught it. So do that. Do it in the margin. Just never hand it in as the proof, because it isn't one. Example 1, the one from the start. Show that x plus 3, all squared, minus x minus 3, all squared, equals 12x. Start on the left, because it's the messier side. Expand the first bracket. X squared plus 6x plus 9. Expand the second. X squared minus 6x plus 9. Now subtract and watch the signs, because that minus goes into the whole bracket. So it's x squared plus 6x plus 9 minus x squared plus 6x minus 9. The x squareds cancel. The 9s cancel. 6x plus 6x is 12x, which is the right-hand side. Done. And in the margin, x equals 2 gave 24 on both sides, so the algebra is clean. Example 2. Show that n plus 1, all squared, minus n squared, equals 2n plus 1. Left side, expand. N squared plus 2n plus 1 minus n squared. The n squareds cancel. 2n plus 1. Right-hand side. Done. And that result is worth a sentence because it means something. The gap between consecutive square numbers is always odd. 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 9. Always odd. Example 3. Algebraic fractions. Show that 1 over x minus 1 over x plus 1 equals 1 over x times x plus 1. Left side. Common denominator. That's x times x plus 1. So the first fraction becomes x plus 1 over x times x plus 1. And the second becomes x over the same thing. Subtract the numerators. X plus 1 minus x is 1. So it's 1 over x times x plus 1. Right-hand side. The whole difficulty in this one is committing to the common denominator on line 1, instead of trying to be clever. Example 4. This one isn't an identity. Show that the product of any two odd numbers is odd. And here you have to define your objects first. That's the step people skip. Let the two odd numbers be 2m plus 1 and 2n plus 1, where m and n are integers. And notice, two different letters. If you use 2n plus 1 twice, you've only proved it for two copies of the same odd number, which is a much weaker statement. Now multiply them out. 4mn plus 2m plus 2n plus 1. And now factor a 2 out of the first three terms. 2 bracket 2mn plus m plus n close bracket plus 1. That's 2 times an integer plus 1, which is the definition of an odd number. Done. Last one, and it's the trap. Show that a plus b all squared minus a minus b all squared equals 4ab. Here's the version that feels natural. Write the whole thing down. Expand both sides. A squared plus 2ab plus b squared minus a squared plus 2ab minus b squared equals 4ab. Tidy up. 4ab equals 4ab. True. So it must be proved. Except it isn't. Look at line 1. Line 1 already asserts the thing you were asked to prove. You assumed it, and then you checked that your assumption was consistent with itself. Mark schemes reject that. Here's the fix, and it's the same algebra written the legal way around. Left side, expand both brackets, subtract 4ab. Right-hand side, identical working, one direction only, full marks. One side, downwards, never both at once, and finish by saying you've arrived. Next video goes back to solving, but with more than one unknown at a time. Systems of linear equations.